Today we're going to begin our pre-chapter 1 review, and what we're trying to do in this pre-chapter is we're trying to cover all the basics of Algebra 1 to prepare you for the beginning of Algebra 2. And so we find sometimes people have holes from things they maybe didn't fully understand in Algebra 1 or maybe didn't cover, and this way we make sure that you have a full working knowledge of Algebra 1 so you're 100% prepared for Algebra 2. And the first thing we're going to do is talk about our exponents. And right now we're going to deal with integer exponents. And so we know that when we repeatedly multiply something, we can write it in exponential form to shorten it out. So if I want to multiply a times a times a times a times a 5 times, instead of having to write out a 5 times, I can write a to the 5th power. A is my base, 5 is my exponent, which means I'm going to multiply the base a times itself 5 times. Same goes for -4 times -4 times -4. I'm multiplying my base of -4 times itself 3 times. And I can even do a combination of terms like 2x. I can do 2x, 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 which means I'm going to multiply the base 2x times itself 4 times. So again, if a is a real number and n is a positive integer, then a to the n translates to a times itself n times, or n factors. N is the exponent. It's read a to the power of n or a to the nth power. Now, what we learn is not only how to write them individually, but how do we do some operations with it? What if I want to multiply exponents? Well, if you have a to the m power times a to the n power, you can make your answer a to the m plus n power. Notice the base a is the same in both cases. In fact, it has to be the same for this rule to work, okay? And so when the base is the same, you add the exponent. So if I have x to the 3rd times x to the 4th, it's x to the 3 plus 4, or x to the 7th. That works for numbers as well. If I have 2 squared times 2 to the 5th power, that's 2 to the 2 plus 5, or 2 to the 7th power. Same thing. And so now let's apply it to some expressions. But notice the expressions start very basic and end a lot more complex, right? So let's take one at a time. So b to the 7th times b to the 4th is going to be, notice the base is the same, so it's going to be b to the 7 plus 4 power, or b to the 11th power. Now, when I go to example b, notice it's a little bit different. Notice I have 3x squared times 4x cubed. So what happens is we're multiplying this times this. Notice the numbers, we've got 3 times 4. Well, I can just multiply my numbers. 3 times 4 is 12. Now, when it comes to the exponents, the numbers that have, or the variables that have exponents attached to them, then I have to use the rule that I just used. Notice the base x is the same in both, so I'm going to add those exponents. So it's going to be x to the 5th power. So it throws a little bit of a curve in there when you have a number or a coefficient in front of the variable, but that's all you have to do. So when we go to c, again, we're in the same predicament. We've got -3x squared times 4x to the 4th, but we have this coefficient. -3 times 4 is -12. And then we deal with our bases of x. We've got x to the 2nd times x to the 4th, so that's going to be x to the 2 plus 4, or x to the 6th. That'll be my answer. When I go to d, notice now I have 2 variables here, and that's okay. So it's -3a cubed b squared times 5a to the 1st power b to the 4th. I recommend that you write that little 1 up there above that a so that you don't forget there's a 1 there. And so we'll go start with the numbers. We'll do -3 times 5 is -15. And then we've got a cubed times a to the 1st is going to be a to the 3 plus 1, or a to the 4th. And then we have b squared times b to the 4th. So it's going to be b to the 2 plus 4, or 6. So there's my final answer. And then we go to the last couple. So again, notice our variables are similar. We have m and n, right? So in the first one, we have m squared, n to the first. In the second one, we have m to the first, n to the fourth. And so now I'm going to start with the m's. So m squared times m to the first is m to the 2 plus 1, or 3. And then n to the first times n to the fourth is n to the 1 plus 4, or 5. And there's my answer. And then we go to the last one. So I'm going to start by doing 3 times 4 is 12. Then I'll do y cubed times y to the fourth is going to be y to the seventh. And then z to the first times z to the second is z to the third. And there's our final answer. So what happens if you get more complex ones, right? They tell you to simplify it, basically multiply these out. Again, same idea, okay? Now notice some of these have a negative in the front, makes it a little bit trickier. I recommend that when you see a negative in the front, think of it as a negative 1 times x squared times y cubed. That way you can kind of keep organized what are numbers, what are variables, and stuff like that. So again, notice in the middle one, x doesn't have an exponent, so I'll put a 1 there, and the last one, y doesn't have an exponent, so I'll put a 1 on that one. And so now let's get to the work of it. Negative 1 times 3 times negative 2. So that's going to be positive 6. Right? Negative 1 times 3 is negative 3, and negative 3 times negative 2 is positive 6. Then we go to the x. X to the second times x to the first times x to the third. Well, I have to add 2 plus 1 plus 3 is going to give me 6. And I do the same thing with the y's. I do 3 plus 2 plus 1, and that's also 6. And so there's my answer. So just take your time. You don't have to answer it all right, like looking at it and know all the numbers. Go item by item by item. So over here in B, I'm going to put a negative 1 in front of that a cubed. I'll put a 1 here with this b. And then I'm ready to start doing my math. So I've got 5 times negative 3 is negative 15 times negative 1 is positive 15. I've got b to the fourth, b to the first, that's b to the fifth. And since we really do these in alphabetical order, I probably should have done a first, but I'll do a squared times a cubed is a to the fifth, because 2 plus 3 is 5. We always put the coefficients first, and then we put the variables in alphabetical order from left to right. In this slide, they're throwing us off a little bit because they're introducing an idea that they didn't really show us in the other ones. And when you look at A, you see that you have minus x squared in parentheses. And then in the second one, you have minus x, and then you have the squared on the outside. And that's a really important fact that we need to differentiate here, and we need to identify the differences. What happens is the exponent always applies to what is immediately to its left. So in this problem, we really have like a negative 1 times x squared. And the squared only pertains to the x value, not the negative 1 that's kind of in front of it, okay? And so this is really like the negative 1 times x to the second power, okay? Kind of separate them out. That's what the first one says. Now the second one, that's the entire negative 1x to the second power. So that's basically saying, hey, we're taking negative 1x and multiplying it by itself 2 times. So notice that the negative 1 is also being raised to the second power, as is the x. And the way we knew that is because notice that the negative and the x are grouped inside, and everything in the group is being raised to the second power. Notice the second refers to the whole group, which is different than in the first one, where the 2, the second power, right, only relates to the x. The negative 1 is not part of it. And so again, that's a little bit tricky to do, but again, we just kind of have to see it as different things because they are really distinct. So when I go to multiply this now, I know that I'm multiplying negative 1 times negative 1 times negative 1, which is still negative 1, and I've got x to the second power times x to the first times x to the first, which is going to be x to the fourth power. So negative x to the fourth power is going to be my final answer. Now, what I could have done is I could have taken this second term, and since I know it's negative x to the second power, I could have just simplified it. A negative times negative 1 is 1, and x to the second power is x squared. And I could have done it like that, and I still would have gotten negative 1 x to the fourth, but I feel like it would have looked a little easier if I had first simplified this one. And again, we go to B, and notice that we're going to have the same scenario here in B. Here, it's like having negative 1 times x to the third power. And over here, I have, it's basically negative 1x times negative 1x times negative 1x. It's the entire negative x times itself 3 times. So if I was going to simplify that, right, I would do negative 1 times negative 1 times negative 1 is still negative 1. X times x times x is x to the third. And now I'm ready to kind of combine them. So negative 1 times negative 1 is positive 1, and x to the third times x to the third is x to the sixth. So here we're just going to simplify expressions. Notice none of the exponents are outside the parentheses, so it's a little bit easier than that last slide. But again, here we have this left side is being added to this right side. So what we have to do is we have to work on each side. So if we simplify the left side, it's going to be 5 times 2 is 10, and x squared times x to the third is x to the fifth. And then we go and we add the right side. 3 times 4 is 12, and then this is going to be x to the 1 plus 4, or x to the fifth as well. Now when it's addition and subtraction work the traditional way, where you can only add or subtract like terms. And for something to be like terms, they have to have the same exact variables, and they have to have, those variables have to be to the same exact exponent. And if they are, then you add the coefficients. 10 plus 12 is 22, and the variable and exponent stay the same. And so that's the final answer. And so again, we do the same thing in the second one. We first multiply the two terms. We get 3 times 5 is 15, and a to the fifth times a to the third is a to the 8. We do the right side. We do, this is like a 1 here, so 6 times 1 is 6, and then we get a squared times a to the sixth is a to the 8. Because a to the 8 and a to the 8 are equal, we know that we can do 15 minus 6 is 9, a to the 8th power, and that's the solution. So on this slide, we're going to start talking about another rule, which is raising a power to a power. And what happens is that when you have a number or a variable raised to a power, here, a is raised to the m power, but then the whole thing is raised to the n power, well, what you can do is you can simplify it by multiplying those two powers. So it's a to the m times n. The other thing is if you have two terms in the parentheses, like an AB, okay, what you end up doing is it's kind of like, think of it as a to the first times b to the first. And so what's going to happen is it's going to be a to the 1 times m, b to the 1 times m. And it's going to look like that. So when raising a power to a power, you're going to multiply your exponents. So again, if you have x to the fourth times, or raised to the fifth power, it's going to be x to the 4 times 5, or x to the 20. If you happen to have, let's say, 2x squared and it's cubed, it's going to be 2 to the third power, and it's going to be x to the 2 times 3 power, or x to the 6. And then, of course, 2 to the third power is 8, and it would look more like that. But again, it's going to be each term inside the parentheses is going to be raised or multiplied to that power. Or the exponent is going to be multiplied to that power, right? So let's try some. So here again, we've got 2x to the third power. Now, obviously, if I was to expand this out the long way, this is 2x times 2x times 2x, repeated multiplication, right? And then again, I could do 2 times 2 times 2 is 8, and x times x times x is x to the third. However, I could use this power to power rule here, because this is the same as, remember, this is like 2 to the first, x to the first. So it's like 2 to the 1 times 3 power, and x to the 1 times 3 power. Well, 1 times 3 is 3, so this is my answer, and 2 to the third is 8, and notice I get the same thing. So again, powers to powers get multiplied. So when I go to b, let's use the shortcut. I know that it's going to be 2 squared times x to the 10th power. And 2 squared is 4, so 4x to the 10. How do I get this 2? Well, that's 1 times 2. And how do I get the 10? Well, that's 5 times 2. So now again here, notice that this negative is inside, so it's negative 2 to the 2nd power, and it's x to the 5th to the 2nd power. So I have to ask myself, well, negative 2 squared and x to the 5 times 2, or 10. Well, negative 2 squared is negative 2 times negative 2, so that's positive 4 x to the 10 power. So negatives are a challenge when it comes to exponents, negative coefficients. They can be challenging. Take your time with them. So then again here, notice that I have the negative 2, and it's going to be to the 3rd power, and the x is going to be to the 4 times 3 power, right? 4 times 3. So it's going to be negative 2 cubed is negative 8, and this is going to be x to the 12th power. I go to, again, E, and this is going to be negative 3 cubed. It's going to be x to the 2 times 3 power, which is 6, and it's going to be y to the 5 times 3 power, or 15. And negative 3 cubed is negative 3 times negative 3, it's positive 9, and positive 9 times negative 3 is negative 27. And so this becomes our answer. Again, I could just do this the long way. I could do negative 3x squared y to the 5th, and I could multiply it by itself 3 times. And just to kind of prove to you here that it works, right? Let's just do it one more time the long way. Notice I've got negative 3 times negative 3 times negative 3, negative 27. X squared times x squared times x squared. Well, that's 2 plus 2 plus 2 is 6. And y to the 5th, y to the 5th, y to the 5th. So that's going to be y to the 15. But again, imagine if this exponent was 7. Do you really want to write this out 7 times? You don't, right? So you definitely want to learn the shortcut. And then again, we come over to here and we have, think of negative xy squared. Now, I'm assuming I might have erased something. Like, I feel like there should have been something here, because right now this is just negative xy squared. I mean, this just is itself. So I'm not sure if I'm missing something that should have been here, but as it is right now, it's just itself. Simplify the expression. Again, more examples of the same. So notice that you've got this left monomial raised to this 3rd power, and then you have the right monomial raised to the 2nd power. Well, first thing is we have to do parentheses and exponents first. Remember your order of operations, right? You've got PEMDAS to think about. So parentheses, exponent, multiplication, division, and addition and subtraction. And so you have to raise it to the 3rd power and the 2nd power before you consider the multiplication, because these are your exponents. So exponents go first. So again, let's kind of go through here and do each side. So I'll do the left side in red. So we've got 3a squared b to the 1st cubed. So that's going to be 3 cubed a to the 6th b to the 3rd. And when I do 3 cubed, I'm going to get 27 a to the 6th b to the 3rd. So this is the left side. Now I'm going to do the right side. I've got 2a cubed b to the 1st, and it's all squared, right? So I've got 2 squared a to the 6th and b squared, which again, actually, let me write it a little smaller. So I've got 2 squared a to the 6th and b squared, and then 2 squared is 4 a to the 6th and b to the 2nd. And so I've got now the left side times the right side. So now let's actually multiply these. So I've got 27 times 4 is 108, I think. And then I've got a to the 6th times a to the 6th is a to the 12. Remember, when we're multiplying, we add our exponents. And b to the 3rd times b squared is b to the 5th. And there's your final answer. So let's keep going and do the other ones in B. Again, we have the left one raised to the 4th power, the right one raised to the 2nd power. So let's start with the left one. I've got 2 to the 4th power, x to the 8, and y to the 12. Remember, powers to powers get multiplied. And 2 to the 4th power is 16. So I've got 16x to the 8, y to the 12, times, right? And now I'm going to do the right side. So I've got, think of this as a negative 1. So I've got negative 1 squared, x squared, y to the 4th. And I've got negative 1 squared is 1, x squared, y to the 4th. And so now I'm ready to, multiply these and get my answer. 16 times 1 is 16. X to the 8 times x squared is x to the 10. And y to the 12 times y to the 4th is y to the 16. And the last one, let's see, we've got a bunch of stuff here, right? So let's first start with this one. 2x to the 3rd power is 2 cubed x cubed, which is 8x cubed. That's that one. Let's go with the next one. I've got xy to the 2nd power, so that's going to be x squared, y squared. Let me go with the third one here, this one. This is just what it is, 4x squared, y squared. It's not raised to any power, right? And the last one here is, do a different color. The last one here is just itself as well, right? Nothing changed there. So now let's simplify this left side. I'm going to multiply 8 times 1 is 8. I got x cubed and x squared is x to the 5th. And then I have a y squared. And then on the other side, this is like a negative 1x squared. So it's going to be negative 4. And then I've got x to the 5th and I've got y squared again. So these, notice they're x to the 5th, y squared. So these are like terms. 8 minus 4 is 4. So 4x to the 5th, y squared. And that's the final answer there. And so for our last slide now, we have to simplify these expressions. So we got to take our time on these and let's just kind of go through them. Again, we have a numerator and a denominator all raised to the 3rd power. So this translates to 3 cubed over x cubed, because I got to basically take the numerator to the 3rd power and then take the denominator. So 2y to the 3rd power is 2 cubed and y cubed. And when I simplify this, it's going to be 27x cubed over 8y cubed. And that's as far down as I could go. That's fully simplified. Now here, notice I have negative 4 to the 2nd power. Now, the negative is not being raised to the 2nd power. If it was, it would look like that, but it's not. So what's happening here, think of the negative 4 as a negative 1. So negative 1 times 4 squared, like that, if that makes sense. So 4 squared is 16. Negative 1 times 16 is negative 16. And that's the answer to that one. This one here in C, again, the only thing being cubed is the 4. So it's like negative 1 times 4 to the 3rd power. So negative 1 times 64, which is negative 64. And that's my answer there. When I get to D, notice the negative and the 4 are grouped together, and both of them are raised to the 2nd power. That means it's negative 4 times itself 2 times. And so that's going to be positive 16. And 4 to the 0 power, well, remember that anything to the 0 power is 1. That's the end of the lesson today. So again, we reviewed a lot, but it's the same basic strategies you've learned before. We talked about combining like terms in addition and subtraction. You just add the coefficients. We talked about multiplying when you have the same base and you have exponents. Basically, the base stays the same and the exponents get added. And we talked about powers to powers, where the base stays the same, but you multiply the powers.